star to delta and delta to star transformation. This is one method in network reduction techniques. So first see delta to star connected system. So this is the delta connected system. This delta connected system is converted into star connected system. So across the branch AB, the resistor is R1. Across branch BC, the resistor is R2. Across branch EC, the resistor is R3. And in case of star connected system, here RE is the resistor between A and N, and RB is the resistor between B and N, and RC is the resistor between C and N. Now we have to find this RA, RB, RC in terms of R1, R2, R3. Let's see the derivation. See here, the resistance between the points A and B will be, here this R1 resistor is parallel to these two resistors. So RAB equal to R1 parallel to R2 plus R3. Similarly, RBC equal to R2 parallel to R1 plus R3. Next, RCA equal to R3 parallel to R1 plus R2. And here RAB equal to RA plus RB. So we can write RAB equal to RA plus RB, and RBC is equal to RB plus RC, and RCA is equal to RC plus RA. So substitute in place of RAB, RA plus RB, then we will get the equations like this. RA plus RB equal to R1 into R2 plus R3 by R1 plus R2 plus R3. And similarly, the resistance between the points B and C is equal into the two systems. That is RB plus RC is equal to R2 by R3 plus R1 by R1 plus R2 plus R3. And next, the resistance between C and A is equal to into two systems. That is RC plus RA is equal to R3 into R1 plus R2 by R1 plus R2 plus R3. Let it be equation 1, and this is equation 2 and equation 3. Now add these three equations, that is 1 plus 2 plus 3. Then we will get 2 into RA plus RB plus RC is equal to 2 by R1 R2 plus R2 R3 plus R3 R1 by R1 plus R2 plus R3. Here these two and these two gets cancelled. And the remaining is RA plus RB plus RC is equal to R1 R2 plus R2 R3 plus R3 R1 by R1 plus R2 plus R3. Let it be equation 4. So subtract equation 1, 2, 3 from the fourth equation. Then we will get 1 minus 4 means we get RA equal to R3 R1 by R1 plus R2 plus R3. Next, 2 minus 4. Equation 2 minus equation 4, we get RB equal to R1 into R2 by R1 plus R2 plus R3. Next, equation 3 minus equation 4, we get RC is equal to R2 R3 by R1 plus R2 plus R3. So here we got RA, RB, RC in terms of R1, R2, R3. So next, star to delta transformation. So in that first, this is a star connection system. Here the resistors are RA, RB, RC, and we have to convert this star into delta. So in this delta connected system, we have the resistors R1, R2, R3. So in this star to delta transformation, we have to find this R1, R2 resistors in terms of RA, RB, RC. Let's see the definition for this. So from star delta transformation, we have the equation 4, 5, 6. So multiply this 5 to 6 plus 6 to 7 plus 7 to 5. Then we will get RA, RB plus RB, RC plus RC, RA equal to R1, R2 square, R3 plus R1, R2, R3 square plus R1 square, R2, R3 by R1 plus R2 plus R3 whole square. So here we have R1, R2, R3, R1, R2, R3, R1, R2, R3. So take R1, R2, R3 as common. So R1, R2, R3 of R1 plus R2 plus R3 by R1 plus R2 plus R3 whole square. So this square and this will cancel. Then the remaining is R1, R2, R3 by R1 plus R2 plus R3. This is equal to RA-RB plus RB-RC plus RC-RA. Let it be equation 8. Now divide the equation 8 by equation 4, 6, 7. Then we will get R3 equal to RA-RB plus RB-RC plus RC-RA by RB. Next equation 6 minus divide by 8. Then we will get R1 equal to RA-RB plus RB-RC plus RC-RA by RC. Next equation 7 divided by 8. We will get R2 equal to RA-RB plus RB-RC plus RC-RA by RB. So these are the derivation for the star delta and delta to star transformation. Next we will solve one problem on this star delta transformation. So this is a question we have given. So in that, so find the voltage to applied across A and B in order to derive a current of 10 amperes into the circuit as shown in the figure. So we have to find the voltage across this A and B terminal. So observe in the circuit. So this is in delta form and this side is also in delta form. So now convert this delta into star. Then we have the formula. So that is R1 is equal to, see, R1 means, see here, first see, this is one delta connection system. So take the delta connection system, next convert into star. Means first R1 is equal to 2 into 4 by 2 plus 4 plus 6. The first circuit, R1 is equal to, means that it this side, this is the R1. So the R1 is the resistor between these 2 and 4 resistors. So R1 is equal to 2 into 4 by 2 plus 4 plus 6. Next R2 is equal to the resistor between 2 and 6. So R2 is equal to 2 into 6 by 2 plus 6 plus 4. Next R3 is the resistor between these 2 points. So R3 is equal to 6 into 4 by 2 plus 4 plus 6. Next, similarly, this side is also we have one more delta. So convert the delta into star. So here the resistors are R4, R5 and R6. See, R4 is between 3 ohms and this 8 ohms. So R4 is equal to 3 into 8 by 3 plus 4 plus 4 plus 6. Next R5 is equal to 4 into 8 by 3 plus 4 plus 6. And RC is equal to 3 into 4 by 3 plus 4 plus 8. So after converting the delta into star, the circuit becomes like this. So this circuit, see, this R2 and this 5 ohm and this R4, these three are in series. So directly add these three resistors, and again here also same. These three are in series. So add these three resistors. So here you will get 7.6 ohms and here is 7.4 ohms. After that, this 7.6 and 7.4 are in parallel. So here the resistance is 1 by 7.6 plus 1 by 7.4. That value is 3.74. Now this 0.6 ohms and 3.74 ohms and 0.8 ohms. These three are in series. So the total resistance between these two terminals is 0.6 plus 3.74 plus 0.8. That is 5.14 ohms. Now in the question he is asking find the voltage between these two ends. So VAB is equal to IAB into RB, and he is given the current is 10 amperes. So 10 into 5.14, that is VAB is equal to 51.4 volts. So this is about star to delta and delta to star transformation.